Welcome to our presentation on Point Pleasant Park's ecological comeback post-Hurricane Juan by Abby Meir, Cecilia Ricks, and Caleb Simmons.
Point Pleasant Park is an urban forest in Halifax. This park holds cultural, ecological, and historical importance, serving as both a recreation space and a vital green space in the city. In September 2003, Hurricane Juan, a Category 2 storm, made landfall with winds surpassing 150 kilometers per hour. It uprooted thousands of trees, causing widespread destruction and altering the park's ecosystem. The level of disturbance and damage caused made it one of the most severe natural events in the region's recent history. This disruption provides an opportunity to study ecological succession, which is the natural process of ecosystem recovery after a disturbance. Over the past 2 decades, data has been collected to monitor how the forest regenerates, including changes in species composition and forest structure. Understanding succession in an urban park like Point Pleasant is particularly interesting because human intervention, such as park management decisions, the park's usage, and human-built structures. These can shape natural recovery. Additionally, this research has broader implications for urban forestry, conservation, and climate resilience, especially as extreme weather events become more frequent. This research not only enhances our understanding of forest recovery, but also contributes to sustainable park management practices.
We came up with 3 hypotheses. The first one is that the red spruce will be the dominant species once the population approaches climax community. The second one is that diversity will decrease as ecological community approaches climax. And the third one is that initially diversity will increase in the park, but over time, dominant species will outcompete the other and will lead to a decrease in diversity as the community reaches climax.
To interpret the changes induced by secondary selection at Point Pleasant Park, 6 study sites were used and were chosen based on the most significant damage incurred by Hurricane Juan. The areas of each site were 20 by 20 meter transects. To determine the changes made by succession, trees and shrubs were used as a study organism, among them being the red maple tree, which was the dominant species in 2023, and red spruce being the dominant species in 2004. The density of the species were counted per individual visually within the 20 by 20 transects and were only counted if their diameter at breast height was greater than or equal to 2.5 centimeters. Growth data was gathered using diameter at breast height, which was measured 4.5 feet off the ground with a diameter tape measure, which was wrapped around the tree to get the diameter. This allowed for the growth documentation over each subsequent year. To determine the effects of succession on Point Pleasant Park, calculations using each of the 6 sites were individually calculated using Shannon diversity, where Pi is the number of individuals in a species over the number of species in a given site. This gives the diversity of that site. Evenness of the sites was also calculated, where S is the number of species in a given site. This gives us the evenness of the distribution of the species across a site. To assess the relationship between these variables over years, linear regression analysis was done to see if the changes imposed by selection by succession caused a significant change in the floral community of Point Pleasant Park. Regression analysis was used because this research is looking at changes over time and the relationship between each variable and time, and how that community may look in future years. One community metric used to assess the changes imposed by secondary succession at Point Pleasant Park, Halifax, Nova Scotia was diversity. Regression analysis was used on the diversity over each of the 6 sites over years from 2004 to 2024. The relationship was significant and positive between diversity among the 6 sites and time, with an R-squared value of 0.34 and an F value of 38.8 at 1 degrees of freedom and 77 degrees of freedom. Also a p-value of 2.3 times 10 to the negative 8. This means that diversity in Point Pleasant Park can be predicted for future years by using the regression equation diversity equals 0.0606 times the year minus 120.85. Because Hurricane Juan damaged so much of the park and removed a lot of individuals from Point Pleasant Park, this left a colonizable opportunity for species that were less abundant due to interactions with other species, like species which had weaker photosynthetic ability. An example of this species would be red maple, which cannot survive in low light levels and is considered shade intolerant. Furthermore, the study Burleigh et al. Did in 2008 claims that damage done by Juan was less ecological than it was physical, as the species which were there before are just recolonizing the land, which is typical of early succession. However, this increase will not last forever. As seen with Figure 2, where it shows species richness over time in Point Pleasant Park, Halifax, Nova Scotia. The regression analysis assesses the relationship between species richness across all 6 sites and time from 2004 to 2024. The relationship was significantly positive between richness and time, with an R-squared value of 0.61, an F value of 128.7, with degrees of freedom 1 and 84, and a p-value of 2.2 times 10 to the negative 16. This indicates that species richness can be predicted for future years by using the equation species richness equals 0.5294 times the year minus 1059.4. While this relationship does indicate richness is increasing, this is likely only because the community is in early stages of succession and competition has not yet set in. As stronger competitors become more abundant, species will begin to be excluded from the area. This could be because climax species become more abundant, which would inherently decrease the diversity of Point Pleasant Park at those 6 sites. Furthermore, the generation time of climax species like red spruce are much longer than that of pioneer species like red maple, which might cause a change in diversity in the future. Therefore, as the community moves towards climax species diversity will decrease because early successive species will be suppressed by climax species.
The red maple species had a density of 0 in 2004, while the red spruce had a density of 7 individuals, both measured from the hurricane's most impactful area of Point Pleasant Park, in a 400-meter square area range. In 2004, the red spruce dominated the red maple. By the red spruce dominating, it proved to be stronger in resilience after Hurricane Guam in 2003. However, in 2024, the dominant species changed. The red spruce, which was previously dominant, had a peak density of 17 individuals, while the red maple species had a peak density of 59 individuals, again in the same 400-meter square parameter. The red spruce was dethroned and the red maple now serves as the dominant species. After Hurricane Juan, the red spruce was more resilient to the immediate damage brought out by the storm than the red maple, which was completely wiped out, displaying a density of 0. The red spruce is a late successional species that has a slow growth rate, in comparison to the red maple, which has a fast-growing growth rate and is an early successional species. Therefore, the red maple was able to adapt to the different environment after the hurricane better than the red spruce. The Acadian forest in Point Pleasant Park has not yet reached its climax community and remains in the early successional stage. This is shown as the red maple is dominant over the red spruce. The red maple has a fast growth rate and is taking advantage of the non-shaded region. We are in the midst of reaching the late successional stage in maximum community. More trees would be grown in the area. We know that isn't the case due to the shade-intolerant species, the red maple, dominated the red spruce due to there being less abundance of trees and more sunlight, being able to shine through to let the red maple grow and dominate. By Point Pleasant Park being a public ground that is enjoyed by many citizens, there are many other influences impacting the success of its growth and recovery post-Hurricane Juan. The many people using the park and stepping on its soil affects its ability to reach climax community, as effective nutrients used to help support the growth of these species are being disturbed. Another factor is that since the urban park is close by building and cars, it is experiencing more rising temperatures and aggressive warming to their environment. This would challenge the ecosystem and the species in it by creating a struggle for the species in the park to survive under new conditions. This could impact the way trees grow, as native species are vital parts of seed dispersal. This is an issue because it reduces the forest's ability to evaporate heat through transpiration, which cools the forest down. The warming air rising causes the land and the soil the trees need to grow to become dry and non-nutritioned. Two-eyed seeing refers to the practice of combining both Western and Indigenous knowledge to find the most beneficial approach. Using these perspectives together, we can maximize our resources for understanding and work towards the best outcome for the Acadian forests. We can apply our knowledge on climate change and use what we know about sustainability to help restore the Acadian forests. These ideas bounce off each other, as we know what causes climate change to occur and the effects it has on our environment. While using the knowledge on sustaining biodiversity, we can reduce the effects of the consequences of global warming, allowing the forest to reach its healthiest state.